Okay. So in this session or in this class, so we are going to discuss about the vapor absorption refrigeration. In the previous class, we discussed about the vapor compression. What are the main components of the vapor refrigeration compression? Vapor compression refrigeration, evaporator, compressor, condenser, and expander. So these are the main four components of a refrigeration system. So in this case, instead of compressor, okay, so instead of compressor, we have another three parts. So we are going to replace the compressor with absorber, heat exchanger, and generator. Okay, so these are the components are there. So it consists of evaporator. What is this? Evaporator. Next component is absorber. What is this? Absorber. So next component, heat exchanger. So what is this? It is a heat exchanger. Okay. So next component is generator. Okay. So this is a generator. So next one is condenser. Next one is expansion. Okay, so these are the components of vapor absorption refrigeration. What are those? It consists of evaporator. Next one is absorber. So next one is heat exchanger. Next one is generator, condenser, and the expansion. Is it clear? So in the vapor compression refrigeration, there are many refrigerants are there. So here particularly there are two types of refrigerants are there. One is ammonia is one of the refrigerant, and another one is lithium bromide. So these are the main refrigerants which is used in the vapor absorption refrigeration. Why? Because the refrigerant has to be absorbed or it has to be dissolved in another medium. Okay. So here usually ammonium is used as a refrigerant. What is that? Ammonium is used as a refrigerant and water is used as the absorber, because ammonia is easily going to dissolve into the water. So that's why ammonia is used as what? Refrigerant. Okay, it is a medium of exchange of heat. Next, water is used as a absorber. Is it clear? Okay, so let us consider what? Let us consider liquid ammonia. Liquid ammonia. What kind of ammonia is this? Liquid ammonia. What kind? So it will be of low temperature, low pressure ammonia liquid. So liquid ammonia is in the evaporator. What happens in the evaporator? The heat will be extracted. It is going to extract the heat from the cabinet or wherever it is been placed. It undergoes what? Ammonia undergoes phase change. So it will be what? It undergoes phase change and undergoes phase change from liquid to vapor. So this low temperature, low pressure vapor ammonia is passed to a absorber which contains what? Weak ammonia solution. I will tell you why it is called as weak ammonia solution. Okay, so it will be passed to the absorber which contains what? Weak ammonia solution, and it will be dissolved in this absorber and it will become strong ammonia solution. This strong ammonia solution is pumped to the where? Generator. It is pumped to the generator. So pumping means what? So we are going to increase the pressure through heat exchanger. So it will be pumped to the generator through heat exchanger. So we are going to get the high temperature, high pressure What kind of ammonia? Strong ammonia solution. Strong ammonia solution is passed to the generator, where it will be heated with the help of heating coil. Where it will be heated with the help of heating coil. So what happens? So the vapors of ammonia are produced. Vapors of ammonia are produced. So this, what kind? High temperature, high pressure, vapor ammonia is passed to where? Condenser. What happens in the condenser? The heat will be rejected to the atmosphere, and once again it undergoes phase change. What happens? Heat will be dissipated, so it will be low temperature, high pressure. What kind of liquid ammonia is passed to the expansion valve, where it expands to what? Low temperature, low pressure, liquid ammonia. Once again it is passed to the evaporator, and the cycle is going to repeat. And one more thing you have to mention here is that, so here the vapors of ammonia are generated, right? So we will be left with what? Weak ammonia solution. Okay, and it will be very hot. So that's why it will be passed to the heat exchanger. So this is the weak ammonia solution is passed to the absorber through heat exchanger. What is the meaning of heat exchanger? See, some of the heat, this will be very hot. So this heat will be transferred to this one. So where strong ammonia solution is going to the generator to increase the efficiency, some of the heat will be transferred to the strong ammonia solution in the generator. Sorry, where heat exchanger, and it will be flows back to the absorber. Why I am going to tell initially it is a weak ammonia solution, not as a water. Initially, before starting the cycle, it will be water only. So once the cycle starts, so the water becomes what? Weak ammonia solution. It will be a not complete water. Hence, we are going to call it as weak ammonia solution. So this is how the cycle is going to repeat. So I am going to explain you once again. Please kindly observe, and that will be helpful for you to prepare your notes. So what is this? Vapour absorption refrigerant. So in vapour absorption refrigerant, the first point, important point is here the ammonia is used as a refrigerant and water is used as a absorbent. And what are the important parts of the vapour absorption refrigeration are evaporator, absorber, heat exchanger, generator, condensers and expansion. So these are the main components of the vapour absorption refrigeration. Next part is the working, how it is going to work. So let us consider what? Low temperature, low pressure, liquid ammonia is in evaporator, where it extracts the heat and undergoes phase change from liquid to vapor. So this low temperature, low pressure vapor ammonia is passed to the absorber, which contains weak ammonia solution. So the vapors of ammonia will be dissolved in that, and it will become what? Strong ammonia solution. This strong ammonia solution is pumped. It's a pump. It is pumped to the generator through heat exchanger. So what happens here? It will be a high temperature, high pressure, strong ammonia solution, which will be passed to the generator, where with the help of heating coil, vapors of ammonia are generated. Okay, so we are going to get what? Vapors of ammonia. What kind of vapors? It will be of high temperature, high pressure, vapor ammonia is passed to a condenser, where heat will be rejected to the atmosphere. Now once again the ammonia undergoes phase change from vapor to liquid. So this will be low temperature, high pressure liquid ammonia is passed to the expansion wall, where it expands to what? Low temperature, low pressure liquid ammonia. And once again the cycle is going to repeat. In this way we are going to reduce the temperature of a cabinet or wherever it is. Is it clear?